Mount St. Helens. The Louwala-Clough is an active stratovolcano located in Skamania County, Washington, in the Pacific Northwest region of the United States. It is 96 miles south of Seattle, Washington, and 50 miles northeast of Portland, Oregon. Mount St. Helens takes its English name from the British diplomat Lord St. Helens, a friend of explorer George Vancouver, who made a survey of the area in the late 18th century. The volcano is located in the Cascade Range and is part of the Cascade Volcanic Arc, a segment of the Pacific Ring of Fire that includes over 160 active volcanoes. This volcano is well known for its ash explosions and pyroclastic flows. Mount St. Helens is most notorious for its paroxysmic eruption on May 18, 1980, at 8:32 a.m. PDT, the deadliest and most economically destructive volcanic event in the history of the United States. 57 people were killed, 250 homes, 47 bridges, 15 miles of railways, and 185 miles of highway were destroyed. A massive debris avalanche triggered by an earthquake measuring 5.1 on the Richter scale caused an eruption that reduced the elevation of the mountain summit from 9,677 feet to 8,363 feet, replacing it with a 1-mile-wide horseshoe-shaped crater. The debris avalanche was up to 0.7 cubic miles in volume. The Mount St. Helens National Volcanic Monument was created to preserve the volcano and allow for its aftermath to be scientifically studied. As with most other volcanoes in the Cascade Range, Mount St. Helens is a large eruptive cone consisting of lava rock interlayered with ash, pumice, and other deposits. The mountain includes layers of basalt and andesite through which several domes of dacity lava have erupted. The largest of the dacity domes formed the previous summit, and off its northern flank sat the smaller Goat Rocks dome. Both were destroyed in the 1980 eruption. Geographic setting and description. General Mount St. Helens is 34 miles west of Mount Adams, in the western part of the Cascade Range. These sister and brother volcanic mountains are approximately 50 miles from Mount Rainier, the highest of Cascade volcanoes. Mount Hood, the nearest major volcanic peak in Oregon, is 60 miles southeast of Mount St. Helens. Mount St. Helens is geologically young compared with the other major Cascade volcanoes. It formed only within the past 40,000 years, and a pre-1980 summit cone began rising about 2,200 years ago. The volcano is considered the most active in the Cascades within the Holocene epoch. Prior to the 1980 eruption, Mount St. Helens was the fifth highest peak in Washington. It stood out prominently from surrounding hills because of the symmetry and extensive snow and ice cover of the pre-1980 summit cone, earning it the nickname Fuji-san of America. The peak rose more than 5,000 feet above its base, where the lower flanks merge with adjacent ridges. The mountain is 6 miles across at its base, which is at an elevation of 4,400 feet on the northeastern side and 4,000 feet elsewhere. At the pre-eruption tree line, the width of the cone was 4 miles. Streams that originate on the volcano enter 3 main river systems: the Turtle River on the north and northwest, the Kalama River on the west, and the Lewis River on the south and east. The streams are fed by abundant rain and snow. The average annual rainfall is 140 inches, and the snowpack on the mountain's upper slopes can reach 16 feet. The Lewis River is impounded by 3 dams for hydroelectric power generation. The southern and eastern sides of the volcano drain into an upstream impoundment, the Swift Reservoir, which is directly south of the volcano's peak. Although Mount St. Helens is in Skamania County, Washington, access routes to the mountain run through Cowlitz County to the west. State Route 504, locally known as the Spirit Lake Memorial Highway, connects with Interstate 5 at exit 49, 34 miles to the west of the mountain. The north-south highway skirts the low-lying cities of Castle Rock, Longview and Kelso along the Cowlitz River, and passes through the Vancouver, Washington, Portland, Oregon metropolitan area less than 50 miles to the southwest. The community nearest the volcano is Cougar, Washington, in the Lewis River Valley 11 miles south-southwest of the peak. Gifford-Pinchot National Forest surrounds Mount St. Helens. Crater, glacier and other new rock glaciers. During the winter of 1981, a new glacier appeared, now officially named Crater Glacier. It was formerly known as the Tulutzen Glacier, shadowed by the crater walls and fed by heavy snowfall and repeated snow avalanches. It grew rapidly per year in thickness. By 2004, it covered about 0.36 square miles, and was divided by the dome into a western and eastern lobe. Typically, by late summer, the glacier looks dark from rockfall from the crater walls and ash from eruptions. As of 2006, the ice had an average thickness of 300 feet and a maximum of 650 feet, nearly as deep as the much older and larger Carbon Glacier of Mount Rainier. The ice is all post-1980, making the glacier very young geologically. However, the volume of the new glacier is about the same as all the pre-1980 glaciers combined. With the recent volcanic activity starting in 2004, the glacier lobes were pushed aside and upward by the growth of new volcanic domes. The surface of the glacier, once mostly without crevasses, turned into a chaotic jumble of ice falls heavily crisscrossed with crevasses and seracs caused by movement of the crater floor. The new domes have almost separated the crater glacier into an eastern and western lobe. Despite the volcanic activity, the termini of the glacier have still advanced, with a slight advance on the western lobe and a more considerable advance on the more shaded eastern lobe. Due to the advance, two lobes of the glacier joined together in late May 2008, and thus the glacier completely surrounds the lava domes. In addition, since 2004, new glaciers have formed on the crater wall above Crater Glacier, feeding rock and ice onto its surface below. There are two rock glaciers to the north of the eastern lobe of Crater Glacier. Geologic history. Ancestral stages of eruptive activity. The early eruptive stages of Mount St. Helens are known as the Ape Canyon Stage, the Cougar Stage, and the Swift Creek Stage. The modern period, since about 2500 BCE, is called the Spirit Lake Stage. Collectively, the pre-Spirit Lake stages are known as the ancestral stages. The ancestral and modern stages differ primarily in the composition of the erupted lavas. Ancestral lavas consisted of a characteristic mixture of dacite and andesite, while modern lava is very diverse. St. Helens started its growth in the Pleistocene 37,600 years ago, during the Ape Canyon stage, with dacite and andesite eruptions of hot pumice and ash. 36,000 years ago, a large mud flow cascaded down the volcano. Mud flows were significant forces in all of St. Helens' eruptive cycles. The Ape Canyon eruptive period ended around 35,000 years ago and was followed by 17,000 years of relative quiet. Parts of this ancestral cone were fragmented and transported by glaciers 14,000 to 18,000 years ago during the last glacial period of the current Ice Age. The second eruptive period, the Cougar stage, started 20,000 years ago and lasted for 2,000 years. Pyroclastic flows of hot pumice and ash along with dome growth occurred during this period. Another 5,000 years of dormancy followed, only to be upset by the beginning of the Swift Creek eruptive period, typified by pyroclastic flows, dome growth and blanketing of the countryside with tephra. Swift Creek ended 8,000 years ago. Smith Creek and Pine Creek eruptive periods. A dormancy of about 4,000 years was broken around 2500 BCE with the start of the Smith Creek eruptive period, when eruptions of large amounts of ash and yellowish-brown pumice covered thousands of square miles. An eruption in 1900 BCE was the largest known eruption from St. Helens during the Holocene epoch, judged by the volume of one of the tephra layers from that period. This eruptive period lasted until about 1600 BCE and left 18 inches deep deposits of material 50 miles distant in what is now Mount Rainier National Park. Trace deposits have been found as far northeast as Banff National Park in Alberta and as far southeast as eastern Oregon. All told, there may have been up to 2.5 cubic miles of material ejected in this cycle. Some 400 years of dormancy followed. St. Helens came alive again around 1200 BCE, the Pine Creek eruptive period. This lasted until about 800 BCE and was characterized by smaller volume eruptions. Numerous dense, nearly red-hot pyroclastic flows sped down St. Helens' flanks and came to rest in nearby valleys. A large mud flow partly filled 40 miles of the Lewis River Valley sometime between 1000 BCE and 500 BCE. Castle Creek and Sugar Bowl eruptive periods. The next eruptive period, the Castle Creek period, began about 400 BCE, and is characterized by a change in composition of St. Helens lava, with the addition of olivine and basalt. The pre-1980 summit cones started to form during the Castle Creek period. Significant lava flows in addition to the previously much more common fragmented and pulverized lavas and rocks distinguished this period. Large lava flows of andesite and basalt covered parts of the mountain, including one around the year 100 BCE that traveled all the way into the Lewis and Kalama River valleys. Others, such as cave basalt, flowed up to 9 miles from the vents. During the 1st century, mud flows moved 30 miles down the Toutle and Kalama River valleys and may have reached the Columbia River. Another 400 years of dormancy ensued. The Sugar Bowl eruptive period was short and markedly different from other periods in Mount St. Helens history. It produced the only unequivocal laterally directed blast known from Mount St. Helens before the 1980 eruptions. During Sugar Bowl time, the volcano first erupted quietly to produce a dome, then erupted violently at least twice, producing a small volume of tephra-directed blast deposits, pyroclastic flows, and lavas. Kalama and Goat Rock's eruptive periods, roughly 700 years of dormancy, were broken in about 1480, when large amounts of pale grey dacity pumice and ash started to erupt, beginning the Kalama period. The eruption in 1480 was several times larger than the May 18, 1980 eruption. In 1482, another large eruption rivaling the 1980 eruption in volume is known to have occurred. Ash and pumice piled 6 miles northeast of the volcano to a thickness of 3 feet, 50 miles away. The ash was 2 inches deep. Large pyroclastic flows and mud flows subsequently rushed down St. Helens' west flanks and into the Kalama River drainage system. This 150-year period next saw the eruption of less silica-rich lava in the form of andesitic ash that formed at least 8 alternating light and dark-colored layers. Blocky andesite lava then flowed from St. Helens summit crater down the volcano's southeast flank. Later, pyroclastic flows raced down over the andesite lava and into the Kalama River Valley. It ended with the emplacement of a dacity dome several hundred feet high at the volcano's summit, which filled and overtopped an explosion crater already at the summit. Large parts of the dome's sides broke away and mantled parts of the volcano's cone with tailless, lateral explosions excavated a notch in the southeast crater wall. St. Helens reached its greatest height and achieved its highly symmetrical form by the time the Kalama eruptive cycle ended, about 1647. The volcano remained quiet for the next 150 years. The 57-year eruptive period that started in 1800 was named after the Goat Rocks Dome, and is the first time that both oral and written records exist. Like the Kalama period, the Goat Rocks period started with an explosion of dacity tephra, followed by an andesite lava flow, and culminated with the emplacement of a dacity dome. The 1800 eruption probably rivaled the 1980 eruption in size, although it did not result in massive destruction of the cone. The ash drifted northeast over central and eastern Washington, northern Idaho, and western Montana. There were at least a dozen reported small eruptions of ash from 1831 to 1857, including a fairly large one in 1842. The vent was apparently at or near Goat Rocks on the northeast flank. Goat Rocks Dome was the site of the bulge in the 1980 eruption, and it was obliterated in the major eruption event on May 18, 1980 that destroyed the entire north face and top 1,300 feet of the mountain. Modern eruptive period, 1980 to 2001. Activity on March 20, 1980. Mount St. Helens experienced a magnitude 4.2 earthquake, and on March 27, steam venting started. By the end of April, the north side of the mountain had started to bulge. On May 18, a second earthquake, of magnitude 5.1, triggered a massive collapse of the north face of the mountain. It was the largest known debris avalanche in recorded history. The magma in St. Helens burst forth into a large-scale pyroclastic flow that flattened vegetation and buildings over 230 square miles. More than 1.5 million metric tons of sulfur dioxide were released into the atmosphere. On the volcanic explosivity index scale, the eruption was rated a 5. The collapse of the northern flank of St. Helens mixed with ice, snow, and water to create lavas. The lavas flowed many miles down the Toutle and Cowlitz rivers, destroying bridges and lumber camps. A total of 3,900,000 cubic yards of material was transported 17 miles south into the Columbia River by the mud flows. For more than 9 hours, a vigorous plume of ash erupted, eventually reaching 12 to 16 miles above sea level. The plume moved eastward at an average speed of 60 miles per hour, with ash reaching Idaho by noon. Ashes from the eruption were found collecting on top of cars and roofs next morning, as far as the city of Edmonton in Alberta, Canada. By about 5:30 p.m. on May 18, the vertical ash column declined in stature, and less severe outbursts continued through the night and for the next several days. The St. Helens May 18 eruption released 24 megatons of thermal energy. It ejected more than 0.67 cubic miles of material. The removal of the north side of the mountain reduced St. Helens' height by about 1,300 feet and left a crater 1 mile to 2 miles wide and 0.5 miles deep, with its north end open in a huge breach. The eruption killed 57 people, nearly 7,000 big game animals, and an estimated 12 million fish from a hatchery. It destroyed or extensively damaged over 200 homes, 185 miles of highway and 15 miles of railways. Between 1980 and 1986, activity continued at Mount St. Helens, with a new lava dome forming in the crater. Numerous small explosions and dome-building eruptions occurred. From December 7, 1989, to January 6, 1990, and from November 5, 1990, to February 14, 1991, the mountain erupted with sometimes huge clouds of ash. 2004 to 2008 activity. Magma reached the surface of the volcano about October 11, 2004, resulting in the building of a new lava dome on the existing dome's south side. This new dome continued to grow throughout 2005 and into 2006. Several transient features were observed, such as a lava spine nicknamed the whaleback, which comprised long shafts of solidified magma being extruded by the pressure of magma beneath. These features were fragile and broke down soon after they were formed. On July 2, 2005, the tip of the whaleback broke off, causing a rockfall that sent ash and dust several hundred meters into the air. Mount St. Helens showed significant activity on March 8, 2005, when a 36,000-foot plume of steam and ash emerged, visible from Seattle. This relatively minor eruption was a release of pressure consistent with ongoing dome building. The release was accompanied by a magnitude 2.5 earthquake. Another feature to emerge from the dome was called the fin, or slab. Quote, approximately half the size of a football field, the large, cooled volcanic rock was being forced upward as quickly as 6 feet per day. In mid-June 2006, the slab was crumbling in frequent rockfalls, although it was still being extruded. The height of the dome was 7,550 feet, still below the height reached in July 2005 when the whaleback collapsed. On October 22, 2006, at 3:13 p.m. PST, a magnitude 3.5 earthquake broke loose Spine 7. The collapse and avalanche of the lava dome sent an ash plume 2,000 feet over the western rim of the crater. The ash plume then rapidly dissipated. On December 19, 2006, a large white plume of condensing steam was observed, leading some media people to assume there had been a small eruption. However, the Cascades Volcano Observatory of the USGS did not mention any significant ash plume. The volcano was in continuous eruption from October 2004, but this eruption consisted in large part of a gradual extrusion of lava forming a dome in the crater. On January 16, 2008, steam began seeping from a fracture on top of the lava dome. Associated seismic activity was the most noteworthy since 2004. Scientists suspended activities in the crater and the mountain flanks, but the risk of a major eruption was deemed low. By the end of January, the eruption paused. No more lava was being extruded from the lava dome. On July 10, 2008, it was determined that the eruption had ended after more than 6 months of no volcanic activity.